week. So that was that for last week. And in this week, we are going to look at data structures in Python. And another interesting concept. All right, so another interesting concept in Python, and you probably were wondering what exactly is data structures. So basically, data structures are basically the arrangement of data for easy manipulation, accessibility. That's basically what data structures are. All right. So it is basically how we organize and store data in a computer so it can be accessed and modified. All right. So before now, okay, the way we store information was variable, and then we do what we assign a single value to what to the variable. So in a situation where we have a collection of information and we want to assign that collection of information to a single variable, right? Now we can do that using any of the Python built-in data structure. Now these structures give us the ability to do what to arrange those collections of information in a way the computer can know what can access and modify them. So that's basically what data structures is. And we have a couple of built-in structures in Python, and we're going to look at them one after the other. All right, so we have lists, we have tuples, we have dictionary, we have sets. But for the sake of this bootcamp, we are going to focus on the first three of them: the list, the tuples, and the dictionary. Sets, you can actually look that up on your spare time. Okay, you can actually look that up in your spare time. It's also a fantastic data structure that can come in handy at any point in time. All right, so without and without wasting any more time, right? We are going to move straight to list, and we're going to just dive straight to our VS Code. So once we explain, we do what we carry as practicals, so that way it stays. And the slide, we can come back and reference the slide, all right, as we proceed. Okay, so without wasting time, let's put on our VS Code and ready to do what to write some code. So quickly, so quickly, I will open my so quickly I will open my all right. So I will, my own folder is in my desktop. So yours could be anywhere. Mine is in my desktop. So I'll navigate to my desktop and then have CodeCamp for beginner. So this is all our code that we've written so far, and we'll keep accommodating them here. So quickly, I'll open up this directory. So if you can actually open up your own folder from here, so you can right click here and have the option of opening in VS Code, then you can actually do that. So for me, I don't have the option of opening in VS Code directly from here. So what I'll do is I'll just go to my command prompt and open it from there. Right. So what I'll simply do is I'll just change directory to where I have our projects folder, which in this case is in my desktop, and we're in CodeCamp 4 beginner folder. So when I get there, then I simply use the command code space and then dot, and that'll open up that directory in VS Code for you. Right. So this was where we stopped in our last class. So the good thing about VS Code is that it's actually it starts from the file you actually stopped in that folder. So this was the last thing we did. So we actually made use of a built-in model to do what to actually randomize a specific number for our guessing game. All right, so that was that for last week. So we just start from here. We just continue from here and then build upon. So I'll create a new file as usual, and I will call this class 6. So we have class 2, 3, and 5. 4 is missing, but we just continue from 5. So I'll call this class 6.5. All right. So we said that data structure are basically what a way of where we can do what where we can organize data for easy modification and accessibility by the computer, right? So I said that before now, if we intend to store a specific data, say I intend to store my name, so I can use it anywhere within our program, then what I will do, I will simply give it a variable name and assign that value to that variable name. So in this case, I will call this name, and I'll say let name be equals to Savior Basi, right? And then I can access Savior Basi anywhere within my program. That was that was what we've been doing before now. So I could just call this name and then I will execute this. So we have our name, the Savior Basi. But then there are times where we have more than one information, a collection of data, and we intend to do what to arrange this data in a way that we can actually access them using one single variable. So that's where data structures now start coming in. So Python actually provide variety of them, and then whichever one suits your need, you do what we actually use it for this arrangement. So in this case, I said that we are gonna start with what we list. So I'll leave that variable there, and we'll start with list. So what exactly is list structure? All right, what exactly is list data structure? All right. So list data structure is basically the collection of data. Remember, all these structures, they are available so we can do so that we can store more than one information, one or more information, right? That's the whole essence of them. But in a situation where I have just one specific value, and then there's no need of me using what a data structure, right? I can simply assign it to what to a single variable like that and do what and use it within the program. But in a situation where I have a collection of them, right? Let's say we have a system that asks you to give it a list of your favorite meal. In that case, the user is not going to input just one single meal, right? It's going to input one or more meals, all right? So that's why all these structures are available. So we can do what we can collect this information and then arrange it in a specific manner. So list on its own is what is a collection of this information separated by comma, enclosed in a square bracket. Should I say that again? So list data structure is a kind of structure that does what? That collects information or data, separate them by comma, enclose them within what? A square bracket. So the key thing there is that they are ordered because they must be ordered. They are ordered information, right? Separated by comma, enclosed in a square bracket. Ordered information, okay, separated by comma, enclosed in a square bracket. That's basically what a list is, all right? And then one key characteristics of a list is that its data is changeable, right? Its data is changeable. It means that the data within it can be changed, all right? They can be modified, all right? They can be modified. They are mutable, right? The data, that's the perfect word. The data is mutable. Let's use mutable there. So it means that the information within this structure, we can access it, we can also do what? Modify it. So how do we do this? I remember that the key things, the key thing about a list is that it must be what? It must be ordered. So it must be ordered, all right, separated by comma, right, and enclosed in square brackets. So that's basically what makes a list. So you get ordered information, separate them by comma, and enclose them within what? Square brackets. So let's say I want to have a collection of fruits. All right. So I could simply do what? List them out in a specific order, right? and then separate each of them was by comma, and then put them in a square bracket. So I'll simply wrap this up in a square bracket, so a square bracket. And then I want to order it starting from mango, and then we keep proceeding. So I have my mango there. So that's my own order, right? Yours may be different. So I have my own order. So in my own structure, I'm saying let mango come first, followed by someone's mic is on. Is there a question? Is there, all right. So then follow after the mango, I want pineapple to follow, right? So I have pineapple here. And then what will follow next would be, let's say, orange. So that's three is okay for me. Yours could be more than that. Remember, this the whole thing of in the whole concept of data structure that it can contain one or more information. The more can be as many as you want. For me, I'm going with just these three. So that's basically what a list. Remember, it follows a specific order from mango all the way to orange. Yours could be any order, right? And then each of the items is what is being separated by what by a comma. And at the end of it, they're being what they're being enclosed in what in square brackets. And that is a list. That's what makes a list. So now I can actually collect what three items and then wrap it up as one structure and assign it to what to one single variable. In this case, I could call this what fruit. Right. So before now, I would have done what I would have had probably fruit one and assign what mango to fruit one, and then have fruit two, and then assign pineapple to fruit two, and then have fruit three, and assign what orange to fruit three, and so on and so forth, depending on how many items is available in that structure. So that is basically what a list is. That's how you create a list, and that's how you insert information in them. So you may be wondering how do we actually display this information, this list information? Well, we still make use of our print function. There is no special function for printing list structure. We still use what the print function. So if I wrap my fruit within the print function, then it will display every item we have in that structure. So if I run this again, we have what we have the entire structure. Question before we continue. Question. No question. Right. So the silence means no question. All right. So our list can also be empty. Right. Our list can also be empty. So it means that we can have a structure with no item. Right. You can have a structure with no item. So I could come here, probably call this, I could call this another structure, and I could call this maybe persons for now. Persons, and then what, and a square bracket. Now if I want to print person, then I could simply just print person, and this should show me what the entire structure, which in this case is what is empty. The structure is empty, means that that structure has no item, but doesn't mean that it's not a list. Of course, it's a list. Remember, a list can take 0 to as many items. But then what qualifies it to be a list is the fact that we have what the square bracket. So if you want to verify this, you can actually use the function type. Remember the type function that returns the in the class of what of a specific data. So if I carry out the type of fruits, then I should have what list. It belongs to what to list data type. So you have what class of list. So it means that when Python sees this, it will treat it as a list structure. So giving you all the rights and permission to do what to carry a certain method in what in the list for a list structure. All right. So moving forward. So you may also be wondering, okay, in a case where we don't wish to actually do what we don't wish to actually display the entire structure. Probably you wanted to actually get what a single item from the list. How do we do that? So that takes us what to accessing list item. accessing list items. All right, so to actually access list item, we follow this specific syntax. All right. So we have to, first of all, we specify what the list name. Now, the reason for that is that your program may have as many list structure as possible. So your program is not limited to having just one list structure at a time. You can have as many as possible. So now, in order to be sure which list you want to actually do what get a specific item from, you need to specify the list name. So what comes first is what is your list name. So this is more like a syntax. I'll comment that out. And then after that is what a square bracket again. And then within this square bracket is the index of that item. So the index is basically the position of that item. That's why I said that what the list structure are ordered. Right? So those items, they are ordered. So once you insert them, they have what they have their position. If you change that position, then a different item actually occupies what that specific index. And then you may be wondering, so how do we get this index? It's simple. It's basically where does this item sit in your structure? So where does this item sit in your structure? By default, your your items in your structure start from 0 all the way to the last item. So it means that if you go to my fruit structure, the first item here is sitting on index 0. The next one is index 1. The next one is index 2, and it continues to the gets to the last item. Right? Please note, the index is starts from 0. That's default in Python. To start from 0 all the way to the last item. Right? So if I wanted to actually access say I want to access only pineapple and not the entire structure, what would I do? I would simply call the fruit name and then square bracket the index of pineapple. In this case, what is 0 and what 1. So in that case, I need index 1. But then if I execute this will not show. So I can wrap this up what in a print so that actually shows. So I can wrap this up in my print, or I can actually assign this operation to another variable and do what and display that variable, whichever way it works. So if I execute this, then I should have just pineapple. And that's what we have right there. Question? No question.
So I have a question.
All right.
What if you have like a hundred fruits? Like you want to do something in
Okay.
your Python program. What do you have like 100 fruits? How will you know its index? Is there like a shortcut to find the index of the particular item you want to pick from the list if it's a very long list?
Okay. Fantastic question. Fantastic question. Yes, there are list methods that we can use to actually get the index of a specific item in the list. All right. We look at those methods. All right. We are moving towards there. All right. So there are methods that can help you return what the index of an item, and also there are methods that takes the index and return the item itself. Right? So those methods actually exist. Those methods actually exist. We will look at them.
Okay, sir.
Right. Any other question? No other question. Right. So let's assume I remove this and I say I want to access index 3. What will be the item that will show for this operation? Which item would display? Which item would display?
I don't
No,
think it would display anything.
You don't think it will display anything? Is
Or
anyone
it will display none.
to display none?
Yeah.
Anyone has something different? Okay, so guys say syntax error. So we have none, we have syntax error. Something different.
So there will be an error message because there's no index for 3. There's
Okay,
no. Okay.
there's no item for the index 3. That's perfect. All right. So let's go ahead and execute this and let's see what happens. Right, so it actually shows an error saying what? List index out of range. So that's exactly what happens if we try to access an item that the index is not available in the list. So we have that error, right? Saying list index out of range. Right. So we could as well look through the entire list. Yeah. We can also look through the entire list and display the information there. So remember, remember the syntax for our for loop, right? Syntax for our for loop. I think we have it somewhere here. Syntax for our for loop. For loop. All right, so this is the syntax for loop. Not really perfect, but then we said that what the for loops actually repeat things, that number of things in a structure, right? So we have that what that list is what is a structure. So that means we can do what we can look through what the actions or the items in that list, right? What do I mean? So let me put another comment there. Looping through lists items. All right. So we have our first, remember, our for keyword. Then what they expect what is the variable name. So I will call this probably items. You could call yours anything. I'll call mine items. And then I'll say for items in, let's say, fruits. I want to say print for now. I want to say print hello. How many times will this action repeat? The action hello. How many times will it repeat?
3
Three,
times.
3 times.
3 times. That's because we have 3 elements in that structure, right? So if we execute that, so I will comment this. I'll comment this. All right, so we have 3 there as well. So if I run this, then we should have hello what 3 times as expected. But that's because for loop does what? Repeat things based on number of items in a structure. So the action here is what? To repeat this based on number of what of items we have what in the structure of fruit. All right. So now we also remember that for each time a loop goes through, that the item in that list is being assigned to the variable of the loop, right? For each time our loop actually repeats, the item in that structure is being assigned to the loop variable, right? Exactly. So it's been assigned to this item. So if I come inside my loop and then I say this item is this items is being assigned, oh, sorry, the items in the structure is being assigned to that loop variable, and then you can use it within what your loop. That is a default behavior by Python. You didn't ask for it, Python does it automatically. So for each time your loop actually execute, or for each time your action actually execute, the item in that structure is being assigned to your loop variable, which in this case, our loop variable here is what is items. So if I come in here and say, before executing the action, hello, show me the list item or the item that's responsible for that particular loop. So if I execute this now, we should now have what? The item, right? And then followed by what? The action. Same thing happens here. Item, action. The item, the action. So it means that after the first loop of showing what? Of showing this hello, the item was being assigned to what? To that specific loop at that time, which in this case was mango. And then the loop goes back again and wanted to do what? To execute the second hello, but then the next item now is being assigned to what? To the loop variable, and it happens like that till it gets to the end of the loop. So I could from this I could just simply comment out that this action and just say the action is I want to at least see those items in those structures. See if I execute this, I can now see the all the items within that structure being listed out accordingly. Is that okay? Do we understand? So
So
there's
I have a
silence.
question.
All right. Ask the
So
question.
what if you want to print a message for only one item in that list structure? What should you do?
So you want to print only one action, right?
Yes, for only one item in the list structure.
Okay. You want to execute the this action for just one item in the list and not the entire item, right?
Yes, sir.
Okay. Did we cover loop keywords, the break and continue keyword?
No, sir.
We did not.
Yes, sir.
It's quite unfortunate. Are you sure we did not cover loop keywords? Rev, did we cover loop keyword?
No, sir.
We did not. Fantastic. All right, so quickly. We have two keywords that we use in loops. This keyword works only in loops, please. You take it outside loop, they're irrelevant. All right, so now these keywords are quickly, please. These keywords are break and continue. So from its name, break actually terminates the loop prematurely. All right. So anyway, along your loop and Python encounters the keyword break, it ends that loop automatically, whether the loop has gotten to the last item or whether the loop has reached the end or not. Once it sees that break is more like the superior, or should I say, final command that says end this loop immediately, instantly. So that's what break does. So if I put break here, the moment this loop starts and this action is being executed, and then Python now sees this, it will end that loop. So it means that this loop here will only execute once and will terminate automatically. So what do I mean? If I run this again, you say that this man here shows just mango and ended the loop. That's how break works. So it ends the loop instantly. That's how break keyword works in loops, both for loop and while loop. So this keyword works on both for loop and while loop. So once Python come across them within your loop, it ends that loop instantly. Then continue, on the other hand, the way continue works is this. So continue actually skips the loop. Please, I think let me just break this down into two lines. So we have break, not there. We have break, we have continue. All right, so just put this one down. So we have break that does what? Ends the loop automatically. Ends the loop instantly. Instantly. Continue skips the current loop. Skips the current loop. All right. So if I come here and I put continue before even showing the action, right, means that this loop will keep looping forever. So it means that this action here would never actually get to execute. All right. So this loop will just loop and then ends without this action doing what? Actually executing. Why? Because when the loop starts, so the loop would have actually gone down the entire action, but then it comes across this continue. So this continue then means abandon whatever code is left behind and just go back and start the loop. That's what that continue does. It simply means once you see me, don't just end the loop. Abandon the rest of the code, go back and start the loop all over again. Right, just skip this particular loop and go back and just continue looping again. That's what that continue does. So if I should execute this, then this man actually loops 3 times, but then the action never executed because when the loop starts in the first time and then it sees this continue. So it means abandon whatsoever code is left behind, go back again and do what? And continue the loop. So it comes back again for what? For the second item. And then was supposed to actually execute again, but then it comes again and say what? Another continue. So it skips again, go back again, and keep doing that till it gets to the what? The last item. Do we understand? Do we understand?
Yes, sir.
any question pertaining to break and continue. So those are loop those are loop keywords, right? So they
Uh,
work. Question.
I have a question concerning that continue keyword. Can you tell Python to continue for a certain number of times, like continue 10 times or continue 3 times, not to continue till infinity? Can you do that?
No, it will continue this loop based on the number of items you have in your structure. So it repeats for the first item, and but then it never gets to the last action. So it continues, meaning that it ended that cycle and goes back to a second cycle, right? So it goes back to what to this second item. And then same thing happens again. It came across what the continue keyword. So it goes back, like it starts the next cycle again. So the continue just keeps starting a new cycle, right? So abandoning the current one and just start a new one. So this one started and then it abandoned it and continue a new one and then abandon it again and continue the new one. So if you have to continue to for a specific item, then just continue. Probably you have to put in like 10 items there, and it will keep continuing for that 10 items. Does that make sense? Does that make
Yes,
sense? All
yes,
right.
sir.
So any other question? Mr. Chinazam, your mic is on. Do you have a question?
So how does that apply to the previous question that I asked? If you
So
want, if you want,
all right. So the question was if you want to actually if you actually want to execute this loop for only one item, then you simply do what? Just come here. So after executing the first action, then you just break the loop. It means that after executing once, end the loop instantly. Does that make sense?
yes, sir.
All right. So can we continue? Any other question? Can we continue?
So, sir, what if you want to print for pineapple, which is in the middle, for only pineapple?
Then you need to construct your if condition, sir. Where you check that when the item is pineapple, then execute the action and then you end the code there. You understand what I mean?
Yes, sir.
So please, I'll get that code from you, Mr. What's the question?
Duncan.
So should I be expecting that code from you, Mr. Duncan?
Like a
That
screenshot.
yes, the finished code where it will only execute for pineapple. Can
Yes,
I?
sir.
So if Mr. Duncan has actually accepted to actually give us the finished code, then I also expect all of us to provide that finished code. Please, I'll get that code. So you need to only execute this action only for the item pineapple. Do we all understand the question? Do we all understand the question? Is there anyone that do not understand that question? All right. So I'll explain the code tomorrow. Is that okay? All right. So let's continue. Let's continue. All right. So I'll leave that for us and we will complete that. So execute this action only when item is what is pineapple. And then end the code, right? End the loop though. All right. So that is how we can do what we can actually loop through list item and do what and actually show the item one after the other. So remember that these list items are what are modifiable. It means that this item can be changed. We can change the item this value to another value. And to do that, I'll just simply copy this and we will put it down here. And then this will be called assigning new value to list items. Okay, so how do we assign new value to list items? So it's similar to actually assessing what the list item itself. So now you need to know what you need to still follow this syntax, because and like I said, your list or your program can consist of as many list structure as possible. So you simply need to know what to access what they need to specify which list do you wish to do what to assign a new value to, and which item do you wish to do what to change the value. So that means you will still follow this syntax where you specify the list name followed by what by the index number, and then we do what we assign value, a new value, and that will update our list, right? So let's assume that we want to change the value of orange. Let's say we want to assume we want to change the value of orange to another fruit, say apple. How will we do that? So we specify fruit, right? And then the index of that item, which in this case is what is index 2, and then we assign a new value. In this case, then my new value here is apple. And then if I should now come and say print fruit after making this assignment, we should have that our list should now be updated with apple. Does that make sense?
Yes, sir.
All right, fantastic. So you may probably be wondering. So far we've had a list with a specific kind of data structure. Is it that the list cannot carry multiple data structure? But the answer is that your list can carry multiple data structures. It can carry all the data structure in Python. Combine all of them and put in one list, and it will still hold those items. So meaning that I can have another list. I'll call this list. Excuse. I'll call this list. We'll call this mixed items, right? And this mixed item will have integers, right? Integer types. We also have float. We also have a string. We also have boolean. Can also have another list inside itself. List of names. Pick a few names in chat session. Gaya the Shima Obi. Right, so let's command again, please. We have Gaius. We have who else is there? Right, we have Shima Obi. All right. So we see that of that will still hold. So if I should comment on this for now, and still come down here and say print mixed items, then you will see that our list will still hold. So you have what the entire structure. So your list can actually contain multiple data structure. If we were to print the last item, how would we do that? If we were to print the last item, how would we do that? Or what index would we be referencing? So I'll copy this and put it down here. I want to print the last item. What index you will be referencing? Let me zoom this out so we see properly. I want to print the last item. What index are we referencing, or should we reference? So I've seen 9.
Index 9.
9, sir.
9,
Yeah.
10. Okay. I've seen 9. I've seen 10. Then the one that has 12. Okay, I've seen -1. Okay, I've seen something different. So I've seen 9. I've seen 12. I've seen 9. I've seen 10. I've seen -1. Anything different? Anything different? All right. So let's indexing start from 0. Okay. All right. So let's try 9. Let's try 10. Let's try -1. All right. So I've seen 9. So I think 9 has the highest. So let's go with 9 first. And let's see what we have. So it says list
You put
index.
fruit instead of mixed items.
Oh, sorry. So this should be mixed items. 9. Okay. So we have that. And we have 10 as well. So this should throw an error by default. Because we do not have an index of 10. I'll tell us why. And we also have -1. So this should work as well. So that gave us the last one. So that actually worked. Right. So now the reason why 10 did not work is because please, this is one item in the list. So the list can contain its own self as well. All right, and then it will be considered as one single item. So even if we have about 1 million items inside the inner list is still considered as one item, and it will be assigned just one index and not for its item within it. Okay, so the thing. And then why -1 also works is because you can also reference your list from the back. And then to do that, you just start from -1, and then it will give you the first last item, and then minus will give you second to the last, minus will give you third to the last, -4 will give you fourth to the last, and so on and so forth. Do you understand?
Please, I have a question.
All right.
Okay, what about if you want to print out the list that is inside the list, like the Gaius now?
Okay,
How do we print out only the Gaius?
to print out the item that's inside the list, right? Not the actual whole structure itself. Okay, that's perfect question. And I was about to ask that question. After asking, is there a question? And probably would have kept quiet and then I would have asked that question. But whoever asked that question has set us off. All right, so let's see how we can do that. Okay, let's see how you can do that. So we know that if we have -1, that we will get what? The list inside the list, right? If I have -1 here, and if I have 9, so let's use 9 though. So if I have 9, I will have what? The list itself, right? I'll have the item, the list item within our mixed item list structure. Now, that actually tells us that what that this, right? Now if I should do this, if I should say A is equals to this, it's the same thing as me saying A is equals to this, right? If I should do this, A is equals to this, and that is basically the same thing of me doing what A is equals to that as well, right? Are we okay? Are we together with that? So if I should also do this, if I should also say A of 1 is basically the same thing of me saying A is equals to that, this operation should be equals to this operation, Gaius, right? If I should also say this of this will also give me the same thing. So now the difference between this one and this one here is that this one, we assign this list to a variable A, and then we use the A here, right, to access the value Gaius. But in this case, we simply just pass the list here directly without assigning the variable, and then we do what we access the first item, which will give us what? Gaius. Are we following? Are we following?
No, sir.
All right. So okay, let me do that again. So I'm saying that if we carry out the operation mixed items of 9 of index 9, then we will have what? This list that's inside here, right? That this operation here is the same thing of is the same thing if I should do what? If I should directly assign that list to what? To the variable A. Do you understand up to that point? Do you understand up to that point? Because I want to be sure that we are following.
Yes, sir.
All right.
No, sir. I still don't understand.
Okay. So let me say it again. So I believe that's Mr. Duncan, right?
Yes, sir.
All right. So now Mr. Duncan, if I should carry out this operation, right, mixed item of index 9, what will be the result? If I carry that operation on this list, what will be returned? What item will be returned? So you can count 0, 1, 2, 3, 4, 5, 6, 7, 8, and 1, and 9. Please remember the list there is what is considered as one item. Is that okay?
Yes, sir.
All right. So now I'm not saying so I could just simply come here and copy this list and assign to this variable. That this operation is similar to what to this one here. Do you understand that?
Yes, I understand.
Okay, we all understand up to that point now, right?
Yes.
All right, so that's perfect. So now having this now, if I should now say, okay, let me access the first item, say Gaius, that I can simply do what? Do a similar thing. Since this is a list as well, I can do what? I can access its own item too by what? By using its own index. And in this case, this list here is being assigned to what? To the variable A. So I could simply say A of what? Of index 0, which will give me what? Which will give me Gaius, right?
Yes, sir.
Okay. So I can also, instead of actually assigning this to a variable A, which is what we did here, and then say A of index 0, I can simply just bring the list itself and put it there, right? And not assign it, and still do what? And still go ahead to do what? To index what? The first item. And this will still be what? Gaius. So this operation is the same with what? With this operation. Do you understand up to that point?
Yes, sir.
All right. So believe we are all on the same page now, right? Is there anyone that do not understand the concept from here all the way down to that point? Anyone? So no one. All right. So similar to that concept, we can do what? We can access the item that's inside the list, that is inside our list. Sorry for that, but then it sounds weird. We can access the item that's inside a list structure. We can access an item that's inside a list, right? By simply doing what? Accessing it similar to how we access the outside list. That sounds complicated. So what do I mean? So it means that if I should carry out the operation mixed item of 9, it simply means that this whole operation here will return what? A new list. But then this new list what is inside and exists and a list item, right? So it means that this man here is returning what? A list that's inside what? A list. So we are accessing what? A list item. But then that list item is also what? A list on its own. So we can simply do what? I can now simply add another square bracket and say, okay, give me what? Gaius. Where this indexing is what is doing what is indexing this whole list, and this other indexing is indexing what? This mixed item list. Does that make sense?
Yes, sir.
Is there anyone that is confused?
I'm confused.
All right, let's I'll clean this up. All right, I'll clean this up again. All right. let's break it down. So if I should print this, right, I'll have what? I'll have a list. Gaius and Chima will be right. I assume that I pronounced that correctly. So we have those lists that contain what? Two items. Are we together? And but then this list is inside where? It's inside the mixed item list, right? Here it is. Here's the list. That's inside what? This whole list. Do you follow up to that point, Mr. Duncan?
Yes, sir.
All right. So now having that list, having this list, if I want to also want to if I want to assign or if I want to access the gaius that is inside this list, how would I do that? I would simply probably come outside and do what and reference it by index 0, right? Because gaius is where it's sitting as index 0 in this list structure that is inside what this big list called mixed item. Do you understand?
Yes, sir.
So I could have just assigned this to a variable a like we did. I could have just assign this to a variable a to make it quite simpler. So a is equals to this, and then I would then simply say print a of what? Of index 0, and I'll have what? I will have gaius. Do we understand?
Yes, sir.
So instead of doing this, you can do this. It did actually make sense, but then I could just simply know it. I would just know that that whatever is being returned here, right, is a list. So I can do what? I can just simply access the item of that list with another index. So I could just come outside here and just put the other square brackets. But if this actually complicate things, then you could just break this down by assigning this operation to a new variable, and then you access the item of that new variable. So if I put this up, then you should see the difference now. So if I put this up here and print it, so we will see the gaius and then the item gaius. So we have what the return list, which is, let me screw this up, which is what this man here that we index. So we index item 9. We indexed index 9 from the mixed item list, which gave us what? Gaius and Chima will be right. And then we now say, okay, having this new list now, I want to index what? The first item, which is what? Gaius. So you can break this down by assigning it to what? A different variable, and then we access another variable, or we could just simply make everything all at once and still make it a bit. Do you understand? Do we
Yes,
understand?
sir. Yes, sir.
Yes.
I understand.
All right. Perfect. All right. So we continue then?
Yes, sir.
Yes, sir.
All right. So that's basically that about this, and so about a mixing of data type, that your list can carry as many data type as possible, and your items can repeat. Please, I can still come here and still have another one, and trust me, this particular one is different from this particular one. Two different ones. The difference is that this particular one is at index 0, and this particular one is aware at index 10. So there are two different values. There are two different values. So your values can repeat in a list. You can repeat the items in the list, and they will not conflict, right? They will not conflict because they are both sitting in a different index. They are both sitting in a different index. Okay, so we also have what we call list methods. List methods, right? So list methods are basically built-in functions that helps to do what? To manipulate these lists. So when we apply this method to a list, it manipulates the list, or it alters the structure of the list, right? And there are a lot of them. Trust me, you do not have to memorize them, right? But whenever you see need to manipulate a list, you could always actually check up if there is a built-in function that can help you accomplish that specific task, right? If we right, so but then there are commonly used ones. There are ones that we use almost often as far as list goes, One of them is the append method. Please, when I say method, I'm basically saying functions, right? Built-in function, built-in methods. So functions are something as method, attribute are something as variables. Okay, that so those words are actually they are interchangeable. It's just that it depends on the context. So if I'm dealing with classes, then I will mostly say method, but methods are basically just functions that exist within a class, right? And attributes are basically variables that exist within a class. Is that okay? So please, when I say method, I mean functions, and when I say attributes, I mean variable. Okay, so those two things can be interchanged. Right, so list methods are like, or should I say list functions are basically those built-in functions. So Python comes as fact function that works on list structures. And when we apply them to a list structure, they alter, they actually alter the list or manipulate the list. And to actually apply these methods, we use dot notation, similar to what we did in the model. So we use the dot notation. So to apply it, we simply specify the list. Please remember, these things are important because we need to know which list are we applying this function to, because your program can do or can carry as many lists as possible, right? It can carry as many lists as possible. So you need to specify the list by providing the list name, followed by a dot, followed by the method name, right? Or the function name. That is the built-in function or the built-in method. You can also create your own custom function. You can also create your own custom function or custom method, right? So after that dot comes the function underscore what name. And since this is a function, we need to do what? Execute it. We need to invoke it, all right? So we need to put that parentheses there. So there are built-in function that actually takes in argument. There are some that does not take in argument. So I'll leave optional argument there, because there are some that takes argument. There are some that does not do one, that does not take argument, right? So that is actually optional. So it depends on the function method. So if you actually want to actually know the list of all of them, you can actually look that up on Google. But I believe that if we should reference one, then we should have a list of all of them. So if I say fruit dots, okay, so that is all of them there available. So VS Code will automatically just know that what should follow should be a built-in method or your own providing or your own custom function or method. So these are the available ones. We have the append, we have the clear, we have the copy, we have the count, we have the extend, we have the index, we have the insert, we have the pop, the remove, the reverse, the sort. So all of them are built-in method. And if you want to see how they work or which of them is text in an argument or how they work, you can look that up in Google. There is no law that says you must cram how this thing works. But then when we start using them, you just know how this one works, right? You just know that, okay, that is how this one works, right? So for me, I've been working with this for a long time. So I just know that append actually adds a specific item to the last part of your list. So the appendix was the actual item you wish to do what to add. We also have clear, and I've used clear also. I know that clear takes no argument, so it basically just empties your list. I have copy. I've used copy as well. I know that copy does actually makes copy of what of your list. Now the reason why there is copy, and then why we cannot actually just do that, they do the usual assignment. I will explain that's because of list mutability from ability, right? Due to list mutability ability. So we cannot just assign a list to a new variable and then we assume that that list has been copied. No, it cannot be copied. If you make changes to one of the lists, it will affect the other list. So that's why there's a copy function. So copy just makes a duplicate of your list. So we have count. I've used count as well. So as well as count takes in what an argument. That's the item you want to count, and then it returns what the number of items in that list. So these things you don't have to actually cram them, right? Please, you can actually head over to Google and then see how these functions, how they work, which of them takes an argument, which of them do not take an argument. But then over time, you will just know them, right? So this thing is just natural. Over time, you know them. And how will you know them? You will know them by covering your laptop and clicking it there and coming back next class, right? But then you know them if you keep using them regularly, right? you start writing projects that should do what that should make use of list structures, and then you start making use of this method. Then you just start knowing them automatically, naturally. Okay. So if you don't know how to actually go to find these things, so you could just simply go to your browser and then just search for list methods in Python. You can have the example, anyone, but then if you just search for list methods, I believe that well, I have this extension on my browser. You can add to yours. The extension is called Gripper. So Gripper is more like a code extension that just provides you basic code snippets, right? It provides you with basic code snippets. So I don't really need to scroll down much to start clicking on links to get what a very simple code snippet. I could just copy it from here. So if I was looking for for loop in Python, and I believe that Gripper should just provide me with a snippet that I can just copy and work with as easy as that, without necessarily doing what, scrolling down to do what, to click on a link to start looking for what, for a code snippet to work with. Please, I am not advertising Gripper in any form. I don't work with them. I don't know them, but I've used their services and it's fantastic. See, you can, if you want to actually do that, you can actually do that as well. You can add it to your own extension. So you can actually go to your to Chrome extension. If you go to your Chrome extension, Chrome extension. So I'm going out of extension store. I'm going out of the scope, right? But then if you go to Chrome extension store, for those that for those of us that are using Chrome, and then just search for Gripper, I believe spelled that way. So that is Gripper. So as you can have mine installed. So when you have yours installed and then you enable it, so you say that when you start searching for basic code snippet like that, Gripper will always provide you one simple one at the top without you necessarily scrolling down to do what, to start looking for these things. So that's the fantastic thing about Gripper. So these are the list methods. So you can say that I don't really need to be able to start scrolling down much to start clicking on links and start reading some long articles to do what, to find, to get what I need. Excuse me, Gripper will do what, will just provide this code snippet. And this code snippet is actually being fetched from somewhere in a web browser, so in a web page, and then it's being displayed here. How Gripper does that is up to the developers. All right, so we have the append, and then so you can see that there is a syntax, there is a comment there. So it takes like, it says what that it takes that the append asks what, add x to the end, what, to the end of the list. Like I said, so there are some of them that takes an argument, like you said, this one here takes what, an argument, this one takes an iterable, and this one takes two arguments, this one takes one argument, this one takes an index, and this one takes nothing. So you can see that there are those that takes nothing, like copy and reverse and clear. Like I said, takes nothing. There's some that takes one, there's some that takes two, and so on and so forth. So let's see how this append works. Let's use one, and in our spare time, you can go back and do and actually test out all this method and see how they work, right? So let's see how append works. So from what we've seen there, the append takes in what, a variable x, right, an object x, right. It could be anything, but it takes in an item within a parenthesis, and then that item is being added to the end of the list. So remember, it adds what to the end of the list. So if I come here and then I add a new item, remember we've changed our orange to apple. So I can just simply add back our orange. Let me be sure that the code that changed that is still active. So I'll uncomment this, and then I'll execute this, and then we should have what, we should have mango, pineapple, apple, and then followed by orange. Orange being the new item that's been added. Okay, so we will naturally display that. So let's, after appending this, let's just see our fruit list now. And if we execute this, so now we have what, orange has been added to the end of the list. I can still append any other thing as well. So I can go to mixed items. So mixed items, and I want to do what? I want to append. Probably want to append KodeCamp 4.0. And then if I should go ahead and display mixed items, we should now have KodeCamp being added to the end of the list. See, if I execute this, we now have what KodeCamp being added to the end of the list. Any question? So that's basically how you can apply this method. The list name followed by a dot, followed by what the list method or the function name or the list method. And then, like I said, some of them takes an argument, some doesn't. So you need to know which one does. So since I've used it for a long time, I actually know some of them that should take an argument and some that shouldn't take an argument, right? But then if I still want to actually, because there's no law that says that I should cram this, I can still come here and then Gripper will give me a summary of this quickly, and then I can just scan through and copy what I want and do what and continue working. Any question? Any question? Any question? Any question? Right, so the silence means no question. Fantastic. So we can come here and then we can still do what? Copy each of these things and do what? Test it out and see how it works on our end. So I'll leave it to us. All right, but then if for those of us that don't have Gripper, you could actually go to, you can just scroll down, use any link. Probably this will work. You can go for this, or you can go for this, you can go for that. That should have an article to what pertaining to what to list methods. So there are a lot of them, right? And if you want to actually cover all, we will end up not covering what we should be covered in today's class. So that's about lists. And I'll ask again one last time question. So the
Hello,
silence
good evening, sir.
sorry?
Good evening, sir.
Good evening.
Yes, sir. Sorry, I'm just attending the class for the first time.
For the
I'm so
first
sorry.
time
Yes,
good time has started.
yes, sir. Yes, sir.
So,
And the reason being that I don't know how to navigate on how to go about it until last week that I was instructed on and they guided me on how to. So I want to ask, sir, like, is there any exercise that you've been giving, whether I can, like, if I can go through them and, do them on my own just to boost myself?
there are two exercises that were given, sir. Rep, please. I will hand you over to the rep. Rep
All
will
right.
tell you exactly what to do. Please, rep, take note of Ibrahim. Ibrahim, please message the rep on Discord group channel, right?
All right.
He will tell you what to do. There are two tasks on ground, sir, and then there's also YouTube videos available, sir. Please
Noted, sir.
videos, do those tasks, and let's be on the same page, sir.
Noted, noted, noted. I'll gladly do that.
Please, I'll
Thank
find
you.
in the next class, sir.
No.
I've taken note of your name.
All right, sir. All right,
Find
sir.
your next class, sir.
All right, sir.
Right.
Thank you so much. Yes, sir.
No problem. No problem. Any other question? Please, Rep, please take note of Ibrahim. Help him in every way possible.
Okay, sir.
All right. All right. So in the absence of question, let's look at another data structure in Python. A very wonderful one that is similar to list, but they have a very slight difference. And this one is called tuple. Okay, so I will shift these boys up. And this one is called tuple. Tuple data structure. And then the difference between this and list is that data is immutable. Immutable. It means that once a tuple is created, that nothing can change again. It means that you cannot add, you cannot remove, you cannot even modify. So that is just that. Every other thing that works for list, if everything that works for list that does not actually changes the structure of the list works for tuple. What do I mean? It means that to assign, no, sorry, you can assign. Remember, tuple is immutable, so you can assign a new value once it's created, is being created. So, but then you can access each item, you can look through the item right? So those are basically just the things that you can do with tuple. But then it once created, it cannot be changed. So to create a tuple, right? What exactly is tuple? It's similar to this man. It is ordered, separated by comma, but then it is not enclosed in a square bracket. This man is actually being enclosed in parentheses. Parentheses. All right. So it means that I can have a tuple of names. So I will call these names probably email or probably grade. Let's call it grade. And this grade could be a grade of what, of 10 students. So 10 students, let's say 5 students. So let's say the first student have about 80, second student had about 20, third student had about 95, the first student had about 55, and then the last student have about 75. And that is a tuple. That is a tuple. And then once it has been created the way it is, nothing else can be done to it. You cannot add to it, you cannot remove from it, you cannot modify it, but then you can do what? You can view it. This is more like view only permission. That is tuple. You can only view it, but you cannot do what? Change it. So to view it, we still use our print, the same print we use in printing a list. We can use it to what? To print a tuple. And you can have what? The entire things. We have other existing prints. So I'll comment this one out, come back and print this out again. We have our tuple right there. And we can still access what? The item. Remember, similar to how we access item, we use square and then followed by what? By index. In this case, if I want to access the first item, I'll simply say index 0. Then I can only view the single what? Index there. And then I can still loop. So I could say for I in grade, and then I say print I, and we can still look through them. Remember, these things are not, we are only viewing ever since, we are just viewing, but then nothing has changed. So then the moment we do what, we try to do similar thing we did in this, where we can assign a new value to it. So we come here and I say, let's grade, let the item that is index 2 in the grade data structure be assigned a new value. Say I wanted to help probably this human that had 20. I wanted to upgrade the score from 20 to something else, probably to 100, right? And then I try to do this. You see, it tells me what, that tuple object does not support item assignment. Once created, it is created. So for this reason, those list method does not work with tuple. The only method that works with them is only method that keeps showing you the item, but it does not modify the item. Example of them, let's go back to our browser and see. So this man here we will remove. So it means that it will alter the structure, right? So that will not work on tuple. But then I could do what? I could count an item. This one just counts, right? And then tells you what the number of occurrence of that item. It does not do what? It does not alter the structure. So this man here will work on our tuple, right? But any other thing that apart from that will alter this that will change the value of the structure will not work. So it means I can try this and say, let's migrate. I want to count how many times we have 80. So this will help. So this will simply give me how many students that has 80, right? Excuse me. And if I execute this, I should have one because we have just one student, just one item that has the value of 80. So that method will work on tuple. But then any method that will alter that structure will not work on tuple. So their pin will not work because their pin will add new item, which tuple does not support. Any question? We finished with tuple. We finished tuple structure. Question. Question. No question. No
Sir,
question.
please can you please recap that too, because I didn't really get it clearly, sir.
All right. So I said that the tuple data structure is similar to list structure. The only slight difference is that one is mutable, one is immutable. List is mutable, tuple is immutable. Here it is. Its data is what is immutable. It means that once you create a tuple, you cannot alter that structure. Nothing goes in, nothing goes out, nothing changes, no value changes, nothing at all changes in it. So it stays there. So to create a tuple is also what an ordered item separated by comma, but then a tuple is what is being enclosed within a parenthesis, right? So that's what we have here. So we have this list of items separated by comma, enclosed in what? In parenthesis. Parenthesis is what we call, is that thing that we call brackets. So this one here, right? Brackets. So that is a tuple. So this is basically a tuple structure now. So if I want to actually confirm this, you could just use the print again, and then you could use the type, my type function. So it returns the type of structure, right? Or the type of data type. So if I should do print grade, print the type of grade, then I should have what? A class of what? Tuple. So you have tuple, class of tuple. So it means that what? That every ability that a tuple should possess in Python, and every functionality and every method that works for tuple can now be used on this structure, because that structure belongs to that class of tuple. So since this is a tuple and it is immutable, so I say that everything that works for list works for tuple, except what will alter what? The structure of what? A tuple will not work for this tuple. So it means that the append method will not work. Assigning a new value will not also work. But everything that allows us to view, like to access a single item, to look through the item and display it, will work for a tuple. That's why we can do what? We can actually fetch a single item from the tuple structure, similar to how we did it what we list, and that will work. And we can do what? We can as well look through it as well. We can look through as we did in list, and that will still work. But the moment we try to go and start doing things that will do what? That will alter that structure, then it will throw an error. Things like this, when we try to do what? To assign new value. Remember, so if I copy this and try to edit it again for tuple, then that should not work. So if I should say print grade, all right, so fetch the item in the second index for grade. Fetch the item in the second index for grade, and then assign what? A new value to it. Assign a new value. So the new value is 10, and then if we execute this, then it says that that's I think there's a problem there. Let's see. So if I say grade, assign, fetch the second item, and then assign a value 10 to it. If I should say, let me go ahead and see our grade now, how it looks after we assign this value, then you will see that that operation did not work. It tells us what? That this man does not support assigning of values. So that's just the difference between a list and a tuple. Do we understand? So tuple is immutable, list is mutable. Question. Do we understand?
Yes, sir.
Unpacking
Yes,
in.
well cleared, sir.
So, sorry?
Answer.
I didn't get us.
I understand it, sir.
Okay. So one last structure before we call it off for tonight. We have about 30 minutes left. We have about 30 minutes left. One last structure. Remember, I said that Python has about 4 built-in structure. We have list, we have tuple, we have dictionary, we have set. But I said for this bootcamp, we will focus on 3. In your spare time, you can look up set structure, right? You can look up set structure. Right. So tuple, dictionary. It's similar to other existing tuples. So to other existing data structure, dictionary. So from its name, dictionary, it's similar to our usual dictionary that comes with a word and then its meaning. And then if you see how dictionary it's been arranged, you see things like this where there is a word, right? And then there's a colon and then the meaning of the word. Basically, that's how dictionary stuff. That's how dictionary is being arranged, right? So that's where that name comes from, dictionary. So this particular kind of structure is that okay. So I'll copy this. Is that this structure is unordered. It means that the order in which we are the order in which we arrange our information does not matter. So it's unordered key value pairs. So this one is no more item, but key value pairs separated by comma, enclosed in curly braces. So curly braces is this one. That thing there. That's curly braces. So that's basically a dictionary structure. So the difference is that the items of a dictionary compared to list and tuple is that the items comes as a key value pair. It comes like this, similar to our usual dictionary. So it comes with a key alongside with what its value, right? This is the key. This is what its value. That's how the structures or the items of dictionary looks like. So it comes in pairs. The item, the value, the item, the value, the item, the value, and so on and so forth. And then at the end of it, all these items is being enclosed. Excuse me, it's being enclosed in what in curly braces, right? In curly braces. So let's see how we can create a dictionary as well. So I'll create a dictionary of person. So a single person, no? Person one, right? For now. And then remember, this will come in what in curly braces. So now each item comes as what as a pair, the key, the value. Now the key is usually um strings, right? The keys are usually strings, right? Things that cannot be modified. So they are basically things that we cannot modify, right? So you want your key to be data type that can be modified like strings, right? So string can be modified, right? Once we dive into string, we will see string can be modified. So once you create a string, you cannot change the character within that string, right? You can't change the character within that string. Is quite similar to tuple, right? So you can't change so that's why it's always advisable that your key should be things that you can actually modify. So mostly or commonly, it's always strings, right? It's always strings. So in this case, I will select my key, the name, right? So in this case, I have a key of name. Remember, this item comes as what key and value. So that is my key. Then what should follow is what is a column. Remember, it comes like this: key and value. And then what should follow now is what the actual value. This value can be of any data type in Python. It can be of numbers, of floats, integer, strings, list, tuple, dictionary again, and rest of them, even boolean value. So in this case, I will say that I have a person that has a name says Savior Basi, and has, remember that this is considered as one item, right? That's one item. So I can put my comma in and provide another item, and I'll call this other one H. That's the key. The value could then be 1,000. That's item number 2. I could now have another one, say gender, and then followed by a male, item number 3, and so on and so forth. Do we understand? And then to display the information of a dictionary, we still use our print keyword, print function, and then this will still work. So if I run this, then I should comment on the other ones out and execute this. We should have our dictionary there. Question. Question. So now you're wondering, okay,
Ask a question.
okay. Please ask your
Does
question.
does the indexing still apply here?
All right. Fantastic question. So remember, we said that dictionaries are unordered. So it means indexing does not actually apply here. It does not work here. Right? So it does not actually work here because the way the way you actually arrange your data does not matter in dictionary. Right? It does not matter in dictionary. Unlike the list and tuple. So list and tuple make use of indexing. That's why they are ordered, right? The way you arrange your data in list or tuple actually matters. So it means that if I should move mango from here to the end, that index 0 can no longer be mango. It will be something else, right? But in dictionary, that does not really matter. So as such, indexing does not apply here. But then how do we actually access this data if indexing does not work? So I would copy somewhere, and then we do what? We edit. So I'll copy this man. And one more thing, this data in dictionary are mutable. What do I mean by data? The values in dictionary are mutable. All right, values in dictionaries are mutable. Let me just add that here. Values in dictionary. Okay, its data or its values rather is mutable, please. It can be changed. Right, so now how do we access a dictionary item? So I call this dict. So for verification, you can also add a type on person 1 and it will tell you what dictionary class. So mean that everything that's pertaining to a dictionary, you can do what you can apply to this man called person 1. So similar to this, you still use your dict name because your program can carry as many dictionary as possible. But then what comes in here is the key and not the index. So you see, wherever it is does not actually matter. Right. So one more thing to note before we go down there is that this is on other key value base. So my comma, and one more thing to note is that your key cannot repeat, but your values can repeat. We'll come back to that. So let's access a single value. Say you want to access the value, save your BASI, right? So to do that, we simply say person 1 square brackets followed by what the key. You will see automatically VS Code. This is one beautiful thing about VS Code, the auto completion and these features that help you do what complete this code almost immediately. Okay, unlike ideally we have to actually type out everything yourself. So in this case, to access a value, we reference what the key, which in this case the key for save your BASI is what is name, and that will give us that will give us the value save your BASI. So if we print this out, then we should have what we should have save your BASI. So you have what we have our save your BASI right there. So what I'm actually trying to say before this instance is that your key cannot repeat itself, because if your key actually repeats itself, the last key will override the previous key. What do I mean? If I come here and I do a comma and have another key that has the same name for savior, right? And then this savior now has the key now has a new name, Abdul. 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 Since I've used my name too much. So now if I should execute this, then if I try to fetch the value for the key name, I will now have Abdul and not Savior. And then you also see that your dictionary did what updated the value for name as well as Abdul, even if we had two names available in the dictionary. So it will remove the first one, this one, out or the picture completely, and then do what? Replace it with the last one. That's one thing. Your key cannot repeat, but then your value can do what? Can repeat. So if I have probably another key called name one that still holds the same value, right? Then you see that that single basi will still be a valid item in the dictionary. So if I run this again, we still have our dictionary that has two keys that are the same but different. Sorry, two values that are the same but different keys, right? And then we still have what? We still have our Basi as the expected name value. Is that okay? Question. 20 minutes ago. Question. The silence means no question. All right.
Hello, sir.
Okay.
Is there a way in which we can iterate dictionary
Yes.
like using for loop?
Yes. We are heading
All
there.
right.
Yeah.
All right, sir.
All right. So now the next thing is that remember I said that dictionary is what is also
Please, I have a question.
okay.
Can we put a dictionary in another dictionary?
Yes, we can. So I can. Yes, we can. We can also have. Let me just do that quickly. We can have another key. Say this key would be called another dictionary, and then it has the following values. And it has All right, guys. So I believe you guys can see my screen now. All right. So we can also, I said we can also have lists inside here. So I have a list. A list. And this can also be 1, 2, 3, 4, 5. And that will still work. So these things can, all these structures can have a lot of other structures within them and nothing happens. So this is how we can actually access what a single value in a dictionary. Now we can also assign value. Remember, these dictionaries are what are mutable as well. So we can assign values. Okay, so for that, we see how we can look through them. So remember, if you are looking through a dictionary, please note this one thing. If you are looking through a dictionary, now if I say for items, excuse me, for items in person one, and then I provide an action, it will do what? It will repeat that action based on the number of items we have in a dictionary, which in this case we have about 1, 2, 3, 4, 5, and 6. So it repeat the action for 6 times. And remember, each of the item is being assigned to the loop variable by default automatically. So we can actually just print that out. But then in a case of dictionary, the value is not being assigned. What is being assigned is the keys. So if I list this, if I print the item, you say that what we will have would be keys and not the values. So you can say that basically we are being what list dictionary name, one, gender, age, and name, which are basically what these keys that exist within our dictionary. That's one thing about looping through a dictionary. What will be sent to your loop variable is not actually the values, but then the keys of the dictionary, which we can in turn do what? Use that to do what? To work. So we know that what is coming in here are basically what? The keys. So, and if it's the keys that are actually coming in, we can actually have access these items using what? This syntax, where we can specify the dictionary name, which in this case is what is person one, and then followed by what? The keys, which in this case, the keys is what will come in here. For each time we do what? We loop. So if I run this now, I can now have the values, which is the expected thing that I wanted to see. Do we understand that? Do you understand what happened there? Do we understand what happened there? Right, so the silence means
Please, can you
that.
explain it again?
All right. So I'm saying that unlike list and tuple, right? When we look through them, all right, and then we execute a specific action based on the item in that sequence or in that structure, that automatically Python does what? Send the item in that list to your loop variable, right? For each cycle, it will send the item from the list or from the tuple structure to your what? To your loop variable. And then it keeps doing that, it gets to the last item in that structure. But in the case of dictionary, it is different, right? So it doesn't send the value to your loop variable. Rather, it sends what? The dictionary key to your loop variable. That's why if you print out these items, if I come here and say, let us print out the items alone, then you will see that the items are likely are going to be the dictionary keys. If I comment on this one out, if I comment on this, you see that the items are going to be what? Your dictionary keys and not your dictionary values. So you have name, which is what? The name key here. We have age, which is what? The age key here. We have gender, which is what? The gender key here, and so on and so forth. All right. But then what if you wanted to at least see the actual values but not the keys? So now we know that for each time this loop actually iterate that we are having what? The dictionary key as what? As items. So and then we say that to view the value or to access the value, we do what? We can simply call the dictionary name followed by what? By the key. So now in this case, the key here will be what? Will be items for each cycle, right? If I go for cycle one, I'll have what? Name. If I go for cycle two, I'll have what age, and so on and so on until I get to what to the last key there. So with that, I can simply do what? I can simply just follow this same syntax here by doing what? Providing the dictionary name and then replacing this key with this variable here. Where items there will always be what? Each key in the dictionary. So now if we execute this, we should now have what? The key being what? Name, and then the key, and then the value for what? For that key, which is what we did here. So the first thing there what is the key. Remember, for looping to dictionary, you get key, not value. So now we printed what? The key being what? Name. And since name is the key, I can use the key to do what? To access the value by doing what? By saying dictionary name followed by what? The key. So now I say after getting the key, do what? Pass it to what? The dictionary name and then fetch the value. So that what we did there. Do we understand? Do we understand? All right. So the silence means that we all understood. Okay, so one more thing, how do we assign value to a dictionary, to an existing dictionary? Right? How do we assign value to an existing dictionary? So to assign value is similar to what we still did. Dictionary name followed by key, followed by what? New value. Which in this case, I can comment this out. And I will do dictionary name here is what? Is person one, followed by what? The key. So the key is age. So I could say let age now have a new value of, let's say, 5,000. And that will do what? And that will assign a new value to what? To the existing key. So now if I now say print person one being our dictionary now, we should now have that age should no longer be 1,000, but the age should now be 5,000. So you have age being what? 5,000. All right, 5,000. Then how do we also add a value? How do you add an item to a dictionary? So it's similar, it's the same thing that we did here. The same way you assign a new value, the same way you add a new value to a dictionary. So how does that work? How does Python knows that this one is assigning and this one is adding? So it will know if you actually specify a key that does not exist in your dictionary, then it will do what? It will automatically create that item and put it in what? In your dictionary. So if I now come here and then provide a key with a new value, please, because if you try to access, if you not provide a new value and then you just put in a key that does not exist, let's say a key here is what? Is KodeCamp, and at the moment there's no KodeCamp in our dictionary, right? If I try to do this, then this will throw an error saying key error, right? Key error. So you can see you have what? Key error of what? KodeCamp. It means that there is no item that has the key KodeCamp. But then if I assign a value to what? To a key that does not actually exist, then it will do what? It will automatically add it as what? As a new item to your dictionary. So if I say let's access a key called KodeCamp, which does not exist, but then provide a value called 4.0, and then Python will now know, okay, this is what that I am to do, what? Add this new pair to what? To your dictionary. Now if I run this now, we should now have a new key or a new pair called KodeCamp that has a value of 4.0. Does that make sense? Does that make sense?
Yes, sir.
All right. Any question? Any question? All right. So no question. No question. So the silence means no question. All right. So by Wednesday, we'll be wrapping up basics of can we copy dictionary values in the chat? I'm lost. How can we copy dictionary value in the chat?
I meant, can you please paste it in the chat?
Well, can I paste that dictionary?
Yes, the last dictionary example. Yes, this one.
This one here.
Yes, thank you.
Okay. Yeah. Hopefully, I should not. All right. So we wrap it. Okay. Let me check. put in the chat session.
I have a question, sir.
All right, what is the question, sir?
Sir, thank you for the lecture so far. You said I should remind you last week about the slides for the lectures. And I think I did
Let me just
remind you, but
do that now, so I don't have to forget again. We begin off this call now, but I'll do that now. All right, so I'll send it now send it now to the group. So I'll
okay,
stop
thank you,
sharing.
sir.
So I'll stop sharing at the moment, so I can actually access my drive. I'll load up the
Okay,
module
sir.
as well. No. Okay, so I'll okay. So before that, I wanted to say that this week we're running up with basis of Python. So once again, I want to congratulate us, all of us that have been on this boot camp from day one up to today. Big congratulations to all of us. From next week, we'll diving into Fast API proper. And please use this week to make sure that you master the basic concept of Python, because we will still use all these concepts that we've been singing and discussing and lecturing. We use it again in Fast API. Fast API is the framework that depends on Python. So,
Okay, so just a quick one, sir.
okay.
So what of those that didn't make it through the first tax, the grid tax? What will be their fate?
So, have you done your grid tax? Yes or no? Let's start from there.
No, I have. I was promoted, but
okay. For those of us that have not done that, please.
No, they have done it, but they were not promoted.
They will be promoted. Then log out and log in again. Log out of the system and log in again. You should be promoted. I believe everyone that did that tax should be promoted.
Okay, thank you, sir.
Right.
Hello, sir.
Okay.
I just registered this thing on the deadline because I wasn't using I just like upgraded my phone, like get a new.
Hello, Sylvia, can you hear me?
Yeah. Yeah. I can hear you, sir.
Sylvia, I can hear you. Okay, good.
Yes, I can.
The last person asked the question, sorry, who was that asked about those who did not go past the please can you identify yourself?
Okay, I am Chinazom. I'm the class rep, sir.
You sound like you're asking on behalf of someone.
Yes, I'm asking on behalf of the class because I'm the class rep, sir.
Yeah, I know you're the first rep. You're supposed to run be a co-host of this meeting, right? So is there anyone in particular, or that was just a generic question?
It was a generic question.
Okay, so is there anybody on this call that has not done their grid task? Anybody, you can raise your hand. Now, to address general. Okay, Ibrahim, you have not done your grid task.
Yes, sir. Like
why?
No, sir, I just like you were even on that told you on how to go. I have see phone, but I just got it rectified. So by God's grace too, I'll do that.
Sorry, I didn't get what you said. Take that again.
Like what happened was that I've listened to but my gadget got spoiled. It wasn't working perfectly, so I just get it rectified.
Okay, so
that's more or less the reason. So I will do it or filling it tonight.
Okay, get that done then.
All right, sir.
Okay, so
thank you.
Well, serious. Hand over to you. I needed to be sure. I wanted to know if there was someone in particular who is having that concern, right? So I think you're the only one on this call, so that's a good one. Shinobi, oh sorry, is it Shinobi? Okay, Chinazom, okay, the first rep. So in case anyone is having that, having any issue, right, you can just reach out to your trainer or you reach out to me directly. Is that fine?
Okay, sir. Thank you, sir.
Yeah, great job. Bye.
Right. So everything has been sorted out, for those that's have been graded but not promoted, please log out and log in, and you should be good to go. All right. So I don't think there's any other question. So we'll wrap it up for tonight.
Sir.
Uh,
Sir, okay.
Okay. Question.
My question, I just want to to the class rep. Sir, please, the necessary information, I will gladly appreciate if I can get it. And I don't know how to link you up on the Discord. I mean the class rep. Yes,
class
sir.
rep.
Busari
rep,
Ibrahim
now.
on the Discord, and my username is Alara.
Class rep, have you noticed that? Rep.
Yes, I have. Alara. Yes,
All right.
Mr. Busari.
All right. So Rep will handle that from there. All right, and will provide you with all the necessary information. Okay. So I'll also do my best to make sure that I will give us access to this folder, our class folder. I'll just zip it and drop it there on the group. So we'll just use it there. All right. So in the absence of any other question, in the absence of any other question, see you guys on Wednesday. Have a wonderful good night rest, and bye for now.